Next topic is summarization. Summarization. Summarization means addition of two or addition of two or more subnet IDs. Addition of two or more subnet IDs belongs to same class full NID. Next point, calculated address called Summary NID and third point, mask of Summary NID will be greater than default mask. The first point is addition of two or more subnet NIDs belongs to same class NID. Second point is calculated address called summary NID, and the third point is mask of summary NID will be greater than default mask. Basically, summarization is a reverse traffic engineering, of the subnetting. In case of the subnetting, we are dividing the bigger space into the smaller space of the same size. Let's say we have the one hall, big hall, and we want to divide that one big hall into the smaller shops of same size. That is the subnetting. And the summarization is totally a reverse process. Let's say you have purchased one space, and in that space you have find multiple shops exist, and you want to increase the size of the shop. So the thing is that we can fall the one wall between the two or three shops. We can increase the size of the shop. Summarization is the reverse process of the subnetting. In that case, we will take the multiple subnet that belongs to the same NID. Let's say all the subnets belongs to the 192, for example 192.168.100.0. it's a major network, and the networks belongs to same NID. We cannot summarize the subnetted NIDs of the two different NIDs. Let's say one NID is 192.168.100.0 and second NID is 199.10.20.0. These are the two different major NIDs. So we cannot summarize, we cannot add the subnet IDs belongs to two different NIDs. We can summarize the multiple NIDs belongs to the same NID. The procedure to calculate the summary address is that if we have the multiple subnet IDs, the first we will convert into the binary format entire subnet IDs, entire octet. And second thing is that after converting into the binary format, we will check how many bits are ideal from left to right. First we will convert all the subnets into the binary format, and second we will check how many octets or bits have the ideal from left to right. Ideal means if all bits are 0, ideal. All bits are 1, ideal. If in a octet 2 bits are 1 throughout and third bit is 0, it's ideal. So when the pattern will change, if all bits are 0, that is the part of the network, and if anywhere the pattern is changed, it means from that point the host bit is started. So first we will take few subnet in decimal and dotted format, and after that we will convert into the binary format. Let's say we have the 3 subnet 199.10.20.4/30. its major NID is 199.10.20.0/24, and it is the part of the major network, and the second network is 199.10.20.8/30, and the third network is 199.10.20.12/30. We want to summarize 3 subnets. Basic principle is that convert all the numbers into the binary format, but it's a wastage of the time. If you are looking in all the subnets, the first octet is common. Any number here, not 199, let's say 10, let's say 20. 199 is common in all the 3 subnets. It means the 8 bits are common in first octet. But in first octet we have the combination of the zeros and 1. In first octet all bits are not 0, all bits are not 1, but it's a combination of the 0 and 1. But we are seeing here all bits are same. In second octet again combination of the bits 1 and 0 is same. In third octet the combination is same. So if you will find out all octet are same, do not convert into the binary format. Just write 255 with respect to the specific octet. 255 and 255. We can say 24 bits are common in all these subnets. We can say 20 bits are common in all the subnets without converting into the binary format, right? Now, but in fourth octet we cannot say how many bits are common. What you will do? You will take the uncommon octet and convert only uncommon octet. Do not convert into binary common octet. Convert only uncommon octet. That is the uncommon octet. 4, 8, 12. 4, 8 and 12. Convert the 4 into the binary format. 0, 0, 0, 0, 0, 1, 0, 0. That is the conversion of the 4. The conversion of 8 is 0, 0, 0, 0, 1, 0, 0, 0. Conversion of 8. And the conversion of 12 is 0, 0, 0, 0, 1, 1, 0, 0. Now, how many bits are common from left to right? This bit is common, and the common bit replace by 1 in case of mask. 1, 1, 1. If all bits are 0, then again we will write the 1 also, because here we are writing the 1, because the conversion of the 10 is 0, 0, 0, 0 and 1, 0, 1, 0. For each bit we are writing the 1, that's why we are getting the 255. In the fourth octet only 4 bits are common and the 5th bit is not common. So from that bit we will write the 0, and if any bits is 0 in the mask, all the right bit will be 0. It's a rule, because in mask you will not see in the future the mask is 255.0, 252.0. It's not a mask. In mask the mask is 32 bits identity, and the second rule is all the bits in the mask will be 1 from left to right. If any bit is 0, all the right bit will be 0. 0. We will not write 1 here because 1 bit is 0. If any bit goes 0, all the bits will be 0 in the right. It means the new mask will be 255.255.255, and what will be the value of this octet? If 4th bit are 1, we will add the 128 here, 64 here, 32 here, 16 here, 240. If the 4 bits are 1 from left to right in the mask, the value is 240. And we can say that 4, 8, 8, 8, 24 and 4, 28. That is equal to /28. The new mask, the new common mask in all the octet is 28 bits are common in 3 subnets. And what will be the block size here? The block size will be 16. What is the power of this one? 16. The last bit I told in the subnetting. The block size is 16. It means the number given to you, they belongs to the block size 16. Block size 16 from where? Because we have the range of an octet is 0 to 255. It may be from 0, it may be start from 16 and plus 16 and plus 16. So we will make one format 0 then 16 in the 4th octet. That is in the 4th octet, 4 OCTET 4th octet. The block size in 4th octet 16. We have to memorize the table of the 16, 16, 32 and 48 and so on. It will go up to the 240. And here I am writing the NID, and that is the next NID, that is the next NID, that is the next NID. From the next ID, previous subnet ID, previous broadcast ID will be -1 from the next. BID is equal to the next NID -1. BID is equal to next NID -1. That is 15, 31, 47, and next is 64, and BID of this subnet will be 63. 0, we will start from the 0. We are breaking the range, entire range from 0 to 15, 0 to 255 via 16. The first block belongs to 16, second block 16, third block 16. First block will start from 0, second block will start from the 16, next start from the 32. And in the given number we have 4, 8 and 12. 4, 8 and 12 is coming under which group? In the first group or second group or third group? When you will fit into the first group, second group, third group? In first group. All are coming under the first group. We have already reserved 24 bits, 199, 10.20. That is already reserved. We have to find out what will be the value of 4th octet. If 4, 8, 12 is coming in second group, this 16 will place here. If 4, 8 and 12 is coming under this group, 32 will put here. But 4, 8, 12 is coming in first group, and the value of first group in the NID is 0. That's why we'll put here 0, and that is our new mask. We'll apply that mask here. The procedure we have completed, called the summarization procedure. The name is summarization, and the resultant we have calculated is summary NID. And the use of summary NID will be in CCNP, not in CCNA. Practical use will be in CCNP. Only theoretical discussion is related to the CCNA.